Okay, everybody, let's do a little video and talk about the different errors that we can have in statistics and how we would work with them or deal with them. So, in general, in statistics, there are two types of errors. That's what we would normally say. For basic statistics, there are more advanced stats that would talk about more types of errors and different things. But the basic two types that we talk about are random errors. Okay, so with a random error, this is something that's unpredictable. It's random. We just couldn't foretell that this was going to happen. Okay, so it's something that's an unpredictable event when taking measurements. I'll say, or recording. So you might think it's an accident, okay, something like that. So often this is called, we would call this human error. So it doesn't happen all the time, but every once in a while we goof up, okay? So I've talked in this class before about measuring my tomatoes some of them I use fertilizer with the tomatoes, and some of them I don't use fertilizer with tomatoes. Going back to that example, let's say that I have so I'm going to talk about tomatoes real quickly. Okay, let's say that I have measurements that I have taken weighing these things, and one of them is 50 grams, and one of them weighed 47 grams, and one of them was 38 grams. And I had a measurement of 48 grams, one of 500 grams, and one of 41 grams. And there were others, but we happen to be looking at this set of the data, this portion of the data set, and we see this guy right here, 500 grams. And everything else that we're taking measurements of is probably in the 30, 40, 50 gram weight area, and this one just kind of sticks out like a sore thumb. And so we would say, uh-oh, something's wrong with that one. Let's go back and look at whichever tomato this was. Either this is a really huge tomato, and if that's the case, then he's probably an anomaly, and we need to talk about whether or not he's an outlier and weird stuff like that. And we'll get to outliers later on in the course, but for right now, we'll say, oh, no, he's the same size as all the other tomatoes, because I think we would have noticed that this one was really huge, right? So we'll ignore the fact that maybe that tomato is 500 grams for right now and say, oh, maybe this was a human error. So maybe we messed up whenever we put it on the scale. Okay, or more than likely, maybe the person who was recording meant for it to be 50.0 grams. Some people like to do that, especially maybe they were making 38.9 or something like that grams. So maybe one person was taking decimals and one wasn't. And then the person who put this into the computer with all the rest of my data set either didn't realize that this person was putting in a 0.0, or maybe they just missed the decimal point whenever they were typing 50.0 and they thought they got it in there, but they didn't. So those are all human errors, no matter which way we go on that. Whether somebody wrote it wrong or read it wrong or typed it wrong, it's all a human error. And it only happened this once in my data set here, so probably it's not something that's consistently happening. It just happened this one time. It's a random error, okay? So that's what we're getting at here is, oh, doesn't happen all the time. Human error, occasionally, okay, that's random. All right, and then the second one, yeah, and this happens a lot when things are done by hand. We'll end up with some weird something like that. The second one is called I'm sorry. I'm sorry. I'm getting ahead of myself. Systematic errors. Okay. So This one is built into the system that I am using. So it's an error that happens all the time when I'm gathering my data or recording my data. Okay, so that's not necessarily because I did something wrong as a human being. It's something that's happening all the time. So maybe something weird is going on that I need to account for. For instance, talking about my tomatoes. I don't know why I'm talking about tomatoes. I don't even like tomatoes. But that's one of my examples that I use in this class for whatever reason. So what if, as I'm weighing my tomatoes, I always place the tomatoes in a bowl, because I don't want them to roll around, on the scale. Now, if you were really doing this particular example, I would hope that before you started gathering your data, that what you would have done was place the bowl on the scale and calibrate it so that the zero weight includes the weight of the bowl as if it was part of my scale, because it's always going to be there. However, somebody, let's say, didn't do that. So the weight of the bowl adds 5 ounces. I'm sorry, we're doing grams. 5 grams to every weight we take. All right. Well, that's not lovely. We don't like that. We should have thought ahead about that particular situation. However, because it happens all the time and it's happening in all of my measurements, it's easy for me to adjust for this. Right? Okay, once I realize my error and that it's systematic, if I have 500 tomato plant weights, I don't want to go back and calibrate my scale after the fact and then reweigh all of those tomato plants. Instead, I'd like to adjust all of my measurements, right, at the end. So systematically, if it's a systematic error, I can do that, because in this case, what would I do? I would just take all of the data points in my computer, and I would tell the computer, subtract 5 grams from every single one of those. And so I would have the original weight, which maybe up here was 50 grams for the first tomato, and I would say original, and then I'd have a column that said adjusted weight, and it would go 50 minus 5, and I'd say 45. This one's 47 minus 5, and the computer would tell me that's 42. So I would very easily and quickly, systematically be able to adjust for that error and get the computer to fix it for me, or I could do it by hand if I needed to, that kind of thing. So those happen very, very easily or it's easy for me to adjust, okay, once I find out what the problem was to begin with. So those are the 2 different kinds. One happens all the time, one is random. Only happens every once in a while. Actually, the random ones are the ones you really got to worry about, because what if a 500 just pops up in the middle of my list and I don't catch it? Well, then if I'm averaging the weights of those tomatoes, the average will be wrong, because the 500 is way bigger than the others and it'll pull the weight up, right? So we have to adjust for that and go, oh, let's go back through our data and find out why all of a sudden my average is like 100 when all of these tomatoes were only around 30, 40, 50 grams. So we got to watch out for that. Okay. Inside of this, we have 2 different ways of looking at these errors, okay? One is we can think of the absolute error, okay? And sometimes this is called the real error, okay? So the absolute error is, how far are you from the true value? Okay, so in the case where, I'm going to continue using my examples up above, in my random tomato case, Well, the one that I measured that was wrong was 500, and we think that the true value, we'll have to go back and measure that particular tomato, but we think that its true value was 50, right? 50 grams. So I want to know how far I am when I measured that guy from what it should have really been. The true value is what the real measurement was, right? Well, I'm off by 450 grams. Yikes! That's huge, right? So that's a big error. The real error that I made there is huge. Okay, so what we're going to talk about here is if I wanted to find that calculation, I just did it naturally right there, we're going to figure out a process for this to know how far am I from the true value. So what do we do? In order to find the absolute error, how far are you away from what you should have had? We took the measured value, or the wrong one, right? This one has the error. And we subtracted the true value, okay, or the real value, okay? And that tells me how far off I am absolutely. So this is just a nice, pretty subtraction problem. It's easy to figure out, no problem, okay? So that is called the absolute error. How far are you away? Okay, that's different from whenever we would take and compare the error that I make to what the value should have been. So sometimes we want to know, it's called a relative error. I can't say the word error tonight. Relative error. Okay. So relative error says how big is this mistake compared to what it should have been? Okay, so basically what we do is we compare the size of the absolute error. So first I have to find the absolute error, right? So I find that. How far off am I? And I compare the size of the absolute error to the true value. So that's the real weight in this case, right? It's not always weights, but because we're talking about tomato weights here, it is. So the true value of the measurement. Okay, so in other words, compared to what it should have been, I want to know how far off you are. In general, whenever I'm doing comparisons in statistics, a lot of times that's going to be a ratio or a percentage, okay? So we're talking fractions, decimals, and percentages here. So in our next section is going to be talking about percentages. So here we go. So in order to calculate this relative error, what am I going to do? Okay, well, I told you we want to compare the absolute error, which we already figured that one out. Our absolute error was 450. So we're going to build a ratio. That guy goes on top, 450, related to the true value of the error, which we said, well, we think that guy was 50. We'll go back and measure him just to make sure. Okay, so the true value of that, and that gives me, well, we can reduce. 45 divided by 5 is 9. Okay, so it's 9 times the actual value. I'm off by 9 times the actual value. So this is my relative error. Now this is a huge error, right? We knew it was bad. Okay, so now that's a ratio. This one happens to reduce nicely, which I picked nice numbers for that. But what if I wanted to know how far off I am as a percentage then? Okay, so this is a ratio. But if I want to know how much is that as a percentage, I'll multiply by 100%. And I'll say we're off by 900%. That's my percentage that I'm off of. So it's 9 times the real value in this case, or 900%. We're too big by 9 times or 900%, which is huge, right? Okay, so that's what we would do for that huge random error that I had. But what about that systematic error, you might say? So can I figure out the relative error? When I used a bowl in my measurements? And that bowl added 5 grams to every measurement, to every data point that I gathered. What about that? Okay, can I figure that one out? Well, the process is actually the same, right? So pick a number, it doesn't matter. I'm going to pick the 45-gram one just because that makes my life nice. And actually that wasn't even in the list up there, but I'm still picking it, so there. So if I want to know, I'm sorry, I'm going to pick the 50-gram one. So the absolute error for the 50-gram one, which was one of the data points, it was the very first one, right? 50 grams. Is 50 grams is what we measured. However, we're off by, well, the actual measurement. So this was my measurement that I measured. This was the true value. So it's off by 5 grams, which we knew. That was my error. Systematic, right? We already figured that one out. So we did that earlier. But just to remind you, that's how I come up with this number. Okay, the 5 grams. Okay, well then I want to know what is that relative to what it should have been. So how big is that error? How far off am I compared to what it should have been? Well, the 5 grams is the mistake. That was my error. And the 45 grams right here is what my true value should have been, right? So look back up here. Oop, I didn't write it down yet. I just did it, but I didn't write it down. I'll give you the actual formula in a second. So it's the absolute error divided by what the true value is. Okay, and I'll write that out in a second. And then whenever I look at that, I go, oh, that is going to reduce again, but now it's 1/9. Okay, so 1/9. So my relative error is 1/9 of the weight that it should have been. And then, of course, I want to multiply by 100% to get it to a percentage. This is the ratio. This gives me the percentage. Whenever I do 1 divided by 9 on my calculator, I get 0.1111, and that goes on forever. And then I multiply that by 100%. I get 11.11%. So it's an 11% error relative to the actual value that it should have been. So how do I find that? Okay, to find your relative error, you take the absolute error, so you have to find that first, and you divide it by the true value. Okay, this gives you a ratio, but normally in statistics, a lot of times we'll say, go ahead and multiply that up by 100% to give me a percentage answer. That tells me what percentage off my measurement was. So this is how far off percentage-wise your measurement was. Okay, so that's what I'm after here for relative error. Okay, so we're going to do an example that doesn't deal with tomatoes. So let me pull this out. Okay, so an example I have from one of the books that I have says, there's a government, the U.S. government says that a particular program costs the taxpayers $99 billion. Okay, so that's what the U.S. government tells the taxpayers. It costs $99 billion. However, whenever an audit is done, it shows that the actual cost is $100 billion. So in other words, they're underestimating how much they're spending. They're not telling us the full truth, however you want to think about that, okay? So let's do some calculations here. First up, what's the absolute error? Okay, now be careful with this because remember that you want the measured value first. So what are they telling me? Okay, what are they telling me? They're telling me $99 billion, right? Okay, and I want minus, go back to your other notes if you need to. Let me find it, sorry. Absolute value, error. Okay, so measured value, where's the error? Okay, the error was in the 99 billion, minus the true value, what was it really? Okay, so here's where the error was, minus the 100 billion, which is the true value. Well, when you do that calculation, be really, really careful because signage matters here, right? So this is negative $1 billion. Okay, so in other words, they're underestimating by $1 billion. That's how much they're off by, which is a huge percentage whenever I'm doing stuff like this, right? So I've got to watch out for that. Okay, so it's too low by 100 or by 1 billion. Okay, they underestimated. Okay. All right. Well, what else? Well, then we might want to know, well, what is that relative to the true value? So how far are they off from what we thought it was going to be? So relative error. Relative error. Okay. Well, let's figure out their relative error, shall we? Pick a different color here. Okay. That brown doesn't want to show up too well. All right, well, in order to do the relative error, what we said was we're going to find that absolute error first, which we already did. We got it right there. We're going to put that on the top of a ratio or a fraction. So whatever your error was, we're going to put it on top, and we're going to divide that by what the real value was or the true value is, okay? So the absolute error here is negative $1 billion. And the real value, what it's really costing us, the true value, was the 100 billion. Right? Does that make sense? That's what we're off by. So now we need to do a little arithmetic. Again, it's negative on top, positive on bottom. Negative divided by a positive is negative 0.01. Okay. I'm going to multiply that by 100%, and I'm going to get it's off by negative 1%. Okay. Too low by 1%. Okay. Which doesn't sound like a bunch. Oh, it's only 1% off. That's not that big of a deal. Well, it is whenever we're talking $1 billion off, right? So, and why doesn't look that big? Well, because the actual value was really huge. So, a big error off of a big number is still a small percentage of that big number. That's what's going on there. Okay, so one more thing that we're going to want to know about as we're looking at some of the homework questions and dealing with them is what's the difference between accuracy and precision? Accuracy versus precision. Okay, and sometimes in the human language, or in the English language, sorry about that. In the English language, we use these words pretty interchangeably, and I do it myself, and you have to watch out for that. So accuracy and precision are not exactly the same thing. So we have to try to be a little more exact with our language. So what's the difference? Okay, if you are accurate, okay, if your estimate is really accurate, then that means you're close to the real value. Okay, so how close am I? Okay, and what do we mean by close? Well, in statistics, that means we want to have a very small relative error. So I don't want to be off by very much, okay? I want to be really, really close to where I should be, okay? So what's the difference between that and precise? Okay. Well, precise is actually about the measurement itself. So accurate is about the error, how far off am I, how close am I, and precise is about the measurement. So how detailed is my measurement? Precise. Okay. So in other words, how many decimal places am I off, basically, right? Or how many decimal places am I measuring? It's the way a lot of times we think about it. Okay. So in other words, if I'm measuring my my tomato plants and one person says that, oh, this tomato is 48 grams, and the other person says it's 48.2 grams, okay. Well, this person is being more precise with their measurement, okay, because they're giving me a little more detail whenever they're taking the measurement. However, maybe this person has some kind of error in their measurement as well, so then they might not be as accurate. So we have to watch out for that. So precision, how detailed is my measurement, versus accurate, how close I am to the real value that I'm trying to measure, okay? So in other words, this person right here who was doing the 50.0 maybe, okay, they may have been very precise in their measurements, but whenever they entered it in the computer, because they made it 500 instead of 50, they were not very accurate with this measurement, right? They were way, way, way off. We know they were 450 grams away from the real value. So being way, way, way off, not a good thing. All right, so let's do one more quick example, and then I'll quit worrying about errors and things like that. In the homework section, there's a problem about the IRS. It's number 9. I don't remember if I assigned it or not. But number 9 out of the book, out of the homework set I'm giving you, is about the IRS. And it says, an IRS agent reviews tax returns to identify the following. Number 1 is mistakes made in calculations. And we all know that those happen. Number 2 is incorrect entries that were intentionally made in order to lower the tax bill. Okay. Incorrect entries intentionally made in order to lower the tax bill. Those are the 2 things that this IRS agent is looking for. And the question says, discuss whether each problem involves a random or a systematic error. Okay. So what are you thinking? In my head, I'm thinking that I hear you say, hey, look at this first one. That's a mistake. It's made in calculations. Maybe I punched something wrong on my calculator, or maybe I just didn't add right in my head, whatever. But hopefully these calculation errors don't happen very often, right? Hopefully they're a one-off or whatever. So this seems random to me. Okay. It's not systematic, it just happened. It's a human error, and those just pop up. That's the way they work. Okay, we try to do what we can to minimize that stuff, but occasionally we're going to have a human error. And that's why, by the way, we do margin of error, is because we know sometimes mistakes happen, right? I might have incorrectly measured one of my tomatoes or whatever. Okay, in this case, we might have incorrectly calculated how much money we spent on, I don't know, charitable deductions or whatever. Okay, the other one is incorrect entries intentionally made to lower the tax bill. Now, this doesn't have to be So it's intentional and it's happening throughout the tax return, right? Or throughout all the tax returns. And people do this, they cheat on their taxes. I'm not saying they don't. But that's not a human error, right? This is something that's happening systemically, okay, throughout all the IRS returns. It might not happen but once or twice on any one person's tax return, but it does happen systemically that people try to cheat on their taxes. And so even if it doesn't happen on every tax return, it's still something that pops up regularly. So this is regular or consistent. So this is systematic. Okay, we like it better whenever it happens on everyone. Not everyone cheats on their taxes, we know that, but it's still more systemic than it is a random. It's certainly not random. It happened on purpose, right? Okay, so that's about it for dealing with errors, and we'll be back talking about percent.